Hello everybody, I'm Suman Matthews, and the video which we will be discussing today is properties of triangles. This is a part of grade 11 math, and for more videos on grade 11 math you can visit my webpage grade11math/mathmadeeasy.co. This video teaches properties of triangles, and this is a part of trigonometry, and this is primarily designed for students of grade 11 mathematics and also students preparing for the JEE entrance. In this section, we learn the significance of non-right angles in trigonometry, and we only discuss applications of these properties. We do not go into details in the proofs. For any triangle ABC, A is the side opposite angle A, B is the side opposite angle B, C is the side opposite angle C. So the first property is A by sin A equal to B by sin B equal to C by sin C. Then we have cos A equal to B squared plus C squared minus A squared by 2BC, cos B equal to C squared plus A squared minus B squared by 2CA, cos C is A squared plus B squared minus C squared by 2AB. This is the cosine property. Now area of triangle ABC is half AB sin C or half BC sin A or half AC sin B. Then we have the projection formula which says that in any triangle ABC, A equal to B cos C plus C cos B, B equal to C cos A plus A cos C, C equal to A cos B plus B cos C. The only way to learn mathematics is to do mathematics, so take a pen and paper and work out these problems along with me. Pause the video in between if you need to, but work through these problems with me. In any triangle ABC, prove that cos A by A plus cos B by B plus cos C by C is A squared plus B squared plus C squared by 2ABC. Using the cosine formula, cos A is B squared plus C squared minus A squared by 2BC, we have the A here, plus cos B is A squared plus C squared minus B squared by 2AC, we have the B here, plus cos C is A squared plus B squared minus C squared by 2AB, and we have the C here. The LCM is common, which is 2ABC, so adding these terms we get A squared plus B squared plus C squared, which is our RHS. Now we need to recollect these proofs, these formulae in trigonometry, namely sin 2 theta is 2 sin theta cos theta, sin A cos B plus cos A sin B is sin A plus B. Coming to the next problem, in any triangle ABC, prove that B squared sin 2C plus C squared sin 2B is 2BC sin A. We start with the LHS, that is B squared sin 2C is 2 sin C cos C plus C squared sin 2B is 2 sin B cos B. So now we can write this as, we have the formula that B squared equal to K sin B because of the earlier property A by sin A equal to B by sin B if we see is equal to C by sin C. If we call this as K, B equal to K sin B, A equal to K sin A, and C equal to K sin C. So we can write B squared as K squared sin squared B, 2 sin C cos C. C squared we can write as K squared sin squared C, 2 sin B cos B. Taking out 2K squared sin B cos C out, sin B sin C out, we get sin B cos C plus cos B sin C. So we get 2K squared sin B sin C. Sin B cos C plus cos B sin C is sin of B plus C. Now A, B, C are the angles of a triangle, so B plus C is pi minus A, and sin pi minus A is sin A. So it is 2K squared sin B sin C sin A. We can group 1K with the sin B, 1K with the sin C. Now K sin B is B, K sin C is C. So it is 2BC sin A, which is our RHS. We make use of this, the earlier property that this is 0, pi by 2, pi, 3 pi by 2 and 2 pi. First quadrant all are positive, second quadrant sin is positive, third quadrant tan is positive, fourth quadrant cos is positive. So sin pi minus A will be in this quadrant, that is sin A. Next problem, prove that C squared minus A squared plus B squared tan A equal to a squared minus b squared plus c squared tan b. We start with the LHS, that is c squared minus a squared plus b squared. Sin a by cos a is tan a. Now to cos a we use the cos property. It is b squared plus c squared minus a squared by 2bc. All the other terms remain the same. So this will be 2bc sin a because these two terms get cancelled. And sin a is a by k. So this becomes 2abc by k. Now RHS is a squared minus b squared plus c squared. Tan b is sin b by cos b. Again substituting the cosine formula for b, cos b is a squared plus c squared minus b squared by 2ac. These two terms get cancelled. You get 2ac sin b. Sin b is b by k. So both LHS equal to RHS. Which property are we using here? A by sin a equal to b by sin b equal to c by sin c equal to k. So sin a is a by k, sin b is b by k, sin c is c by k. In triangle ABC, if b squared minus c squared by b squared plus c squared equal to sin b minus c by sin b plus c, prove that it is either a right angled or isosceles triangle. We start with the RHS here. Sin b minus c by sin b plus c, multiply and divide by sin b plus c. Now sin b minus c into sin b plus c is sin squared b minus sin squared c, and this is sin squared b plus c. So it becomes sin squared b minus sin squared c. By sin squared b plus c is 180 minus a by sin squared pi minus a, which is sin squared a. And sin squared a you can now multiply and divide by k squared. So it becomes k squared sin squared b minus k squared sin squared c by k squared sin squared a. K sin b is b, so it is b squared. K sin c is c, so it is c squared. And k sin a is a, which is a squared. Now your LHS is b squared minus c squared by b squared plus c squared. And the RHS is b squared minus c squared by a squared. So we are equating RHS to LHS. So that means either the numerator is 0, that is b squared minus c squared equal to 0 implies b equal to c, which implies that the triangle is isosceles, or if the numerator is not 0, b squared plus c squared equal to a squared. That means the triangle is right angled. So formula used here is sin b minus c into sin b plus c is sin squared b minus sin squared c. Was this video useful? Please hit the link. If you like it, please hit the like or subscribe button, and do send me your feedback through a comment.